So up to this point, we've been focusing on what switches are and why we'd actually want to use them in our environment. We have a really good understanding of that now. But if we truly want to be able to work with switches and especially troubleshoot them, we really have to understand how they do what they do. So for example, what's going to happen when a frame arrives on the actual switch? But then the type of frame is really going to determine what the switch does with it.
So how many types of communication do we have inside of Ethernet? We need to think about this for a moment because we're going to see and really focus on two of the three. There's unicast communication. There's multicast communication. We won't care too much about multicast communication. And then there's the type of communication that appears to be going on in the first step here, Raymond, broadcast communication. Raymond, what makes a broadcast a broadcast?
Well, a broadcast is sent to absolutely everybody. So we have to be reminded of what the actual MAC address of that broadcast frame is going to be. And it's going to be all Fs. What does that mean? It means that every single binary bit of that 48-bit MAC address is a 1.
So when do we actually broadcast? I mean, we talk about these things where we don't actually love broadcast communication. It's a little bit inefficient because we're blasting it to everyone, and we like targeted communication instead. But think about the common triggers for a broadcast on an Ethernet environment. Raymond, I'll come up with one. A DHCP discover. A DHCP discover, somebody asking for an IP address. That's one typical cause for a broadcast. What's another one?
An ARP request. When we actually have to figure out the MAC address of an IP address we already know about.
And that actually is what's going on here in step 1. Let's look at step 1 so we can view the sequence of events. So in this case, we've got some communication that we want to get from A to B. And specifically, we have an ARP request from PCA to PCB. We're trying to really ascertain PCB's MAC address. PCA doesn't know PCB's MAC address yet. So we have an ARP request going on. And as Raymond just told us, when we do an ARP request, are going to be sending to the all F's MAC address, which makes it a broadcast. That actually is the trigger. Now, Raymond, I'm looking here on step 1, and what I see is an empty MAC address table on the switch. What does that mean to us?
Well, it simply means that our switch has not received any frames yet. It might be a brand new switch out of the box. It might have just been rebooted. There's many different reasons, but essentially what it boils down to is that nothing is in that MAC address table until we restart receiving frames. So we start receiving frames, and our switch is going to look at that source MAC address field of the frame when it receives it. Now, in this case, what is the source MAC address field of our frame actually going to show? Well, it's going to show the MAC address of that device the frame came from. So who sent this frame? Well, it's PCA. So since PCA sent this frame, and this frame arrived on port 1, well, our switch now has the ability to associate the MAC address that it sees in that source field of the frame with the port it came in on. And this is a really important process. This is how our switch learns who's connected to which port, or who is downstream off of that port.
So on step 2, we see the switch learn something, which is great. So these are learning devices, and they're focused on learning where MAC addresses are. But in this case, we still have to revisit the fact that we're dealing with a broadcast frame, right? So a broadcast frame is supposed to go to everyone. And on step 3, we see the true nature of how a switch responds whenever it receives traffic that doesn't already have an entry in the MAC address table, specifically an entry for the destination. So think about the destination one more time here. Destination is going to be all Fs, right? We could look at the MAC address table. Raymond, I don't see the all Fs MAC address associated with a port on the switch. Is that a good or a bad thing?
That's a really good thing. We never want to see the all Fs MAC address associated with a specific port. Why? Because those frames are supposed to go to absolutely everybody, not just one port.
So in step 3, we can actually see a very important rule. And we're going to play out this important rule throughout our discussion anytime we're dealing with a switch and the way that it forwards frames. I want you to read this. It says, the switch floods the frame to all ports except the port on which it received the frame. It doesn't want to go back, doesn't send it back out, because that actually would cause a loop for layer 2 communication. We don't want that. Okay, we don't want that. But it fans out to the rest of the ports. Think of it that way. It fans out to the rest of the ports. So that's really the phrase that pays. It comes in on a port and floods the frame to all ports except the port on which it received the frame, which is what it needs to do anytime it receives a broadcast or multicast. And we're going to see that it can also do this for unicast if we haven't happened to learn about that destination MAC address yet. Okay, so Raymond, this was an ARP request. What do we expect in return after we send the ARP request to everyone on the LAN?
Well, when I send an ARP request, I expect a reply. So we're looking for an ARP reply here. So if we look at step 4, we can see that PCB is going to respond to this ARP request. But why? Well, first of all, we were looking for the MAC address of PCB. So our ARP request said, hey, if you have the MAC address that's associated with this IP address, please give it to me. That's what we were asking for. So PCB's like, hey, that's my MAC address. All right, so I'm going to reply to this. So sends me the ARP reply back. Now, notice what I said. It sends me the ARP reply back. That's important because we aren't broadcasting an ARP reply. No. It's unicast now. It's coming back directly to me. So how do we accomplish that? Well, we are going to have our MAC address of PCB in the source MAC address field and the MAC address of PCA in the destination MAC address field. Now, do I know the MAC address of PCA? Yeah, PCB does know that. Why? Well, because the frame that I originally received, that ARP request, would have had PCA's MAC address in it. So I have the information I need to send a unicast frame back now. So that gets sent out, and our switch receives that on port 3, Dan. And what's going to happen here when the switch receives a unicast frame on port 3?
Well, let's remember that we still have the underlying goal of populating our MAC address table. And so we have a new MAC address that we just discovered by listening to a frame. And this is what a switch does. It listens to every single frame looking, hey, is that a new MAC address? Is that a new MAC address that I don't know about? Or is it a MAC address that I expected in one place and have to reassociate with the new port because it moved, which is actually a possibility. But here, Raymond, okay, so I associate PCB's MAC address, which just sent me some communication, on port 3. So from my mind, we don't have a lot going on here. We just have 2 MAC addresses. We have a fully populated MAC address table on our layer 2 switch.
So we are looking at this frame now, and we've populated the MAC address table, but I still have to do something with this unicast frame. I'm just not going to hang on to it. So in this case, when I look at the destination MAC address, what does it say? Well, it's the MAC address of PCA now. It's the MAC address of PCA. So am I going to flood that out every single port except the port it came in on? No. No, why in this case? Because I actually have an entry in my MAC address table. Look at the MAC address table. Look what it says. It says PCA is out port 1. That's great. It's great. So I'm only going to send this unicast frame specifically out port 1 now towards PCA. It's not going to go out port 2. So this process of learning. Through the source MAC address field of the frame is very important for our switches. We want to learn MAC addresses. We want to associate them with ports. This makes our forwarding process much more efficient. But Dan, is this really enough here for us? Do we truly understand everything that's going on?
Well, we've got a good introduction to the world of Layer 2 switching, but we need a deeper understanding in order to be successful with this at any level. This is our one really great opportunity to get you prepared for examination and also to get you prepared for when you need a deeper understanding of this, when it comes up with security or multi-layer switching or troubleshooting a Layer 2 environment. You need a keen awareness, not just a superficial awareness of what happens at Layer 2, and we're going to give that to you now.